all great questions. So maybe we can move on to our next segment of our interaction, which is more about kind of higher level, meta level thinking about what are the important areas in computer science, or in general, what what career should I be looking at? These are my interests. Why, what are the best options here? What are the best options there? Why is it that I see this is happening, but that is not happening? Whatever, right? So whatever questions that come into your mind. In fact, I'm going to start with one of the questions from Aditya Senthil Nathan, which he asked last time, and we just kind of going to start with that question. And he asks, it's clear that there's a lot to be done in programming language research. But when I search for bleeding edge work in the computer science industry, it's always open source or academic research. And seeing some discussions on Reddit, it seems there is a funding issue for this field and there isn't demand for compiler engineers in the industry. I sincerely hope I'm wrong about this because I like this field. Could you please talk a bit about this? If I'm not wrong about this, why don't people focus more in this field? So first of all, thank you for this question and thank you for liking this field. And I would just say that I don't really agree with some of the statements that you may have kind of picked from Reddit or any other source. For example, the claim that there is not enough funding in this field, not true at all. At least not to my knowledge. First of all, I want to say that everybody has their own perspectives. Nobody really, very few people perhaps have a bird-eyes view of what's going on in the world in a macro level. I can just share my own view, but it's definitely not the bird-eyes view of the whole world or anything like that. But from my perspective, I really don't think there's a funding issue in this field. There's a lot of funds that are being sanctioned for research in programming languages, systems, compiler design, things like that. There isn't demand for compiler engineers in the industry. I couldn't disagree more. I don't think so. Compiler engineers are a hot commodity. They have been a hot commodity. They will be a hot commodity, hopefully. And so, no, I don't, not my experience at all. Why is it that bleeding edge work in CS in this area is always open source or academic research? Well, even that is not entirely true. Well, one of the reasons that compiler design and optimization has been mostly open source or academic research, I'd say mostly, right? There's a lot of commercial work that's going on, is precisely because of the reason I mentioned earlier in the discussion today, which is that it's not possible for a single organization to actually take on such a difficult problem all by its own. And so you need lots of hands coming together to be able to chip at this important but difficult, very challenging problem. And so one of the models that has emerged is that you keep things open source. You keep a permissive license, so people can kind of take back from it and then contribute whenever they like and take back and then use it for the commercial purpose. And those are the kind of models that have emerged mostly. Things like GCC, LLVM, and the other compilation of frameworks for different kind of things. So there are some things that are really popular in the open source world, but then there are kind of variants of it that are kind of proprietary, that are being used by these big organizations, and they have large teams dedicated to improving, maintaining, and things like that for improving those variants. And what they typically do is they draw out from the open source world, and then when it suits their own business interests or commercial interests, then they push it back to the thing. So because there's no kind of force, there's no compulsion to kind of immediately push it back or anything like that. So some of these licenses are permissive enough to do that. So yeah, I mean, there's both commercial, industry, and open source work that's being done in programming language research. It's not just about optimization, but it's also about a lot about correctness, identifying of test inputs automatically, verification work, all these basically come under the purview of static analysis, which is basically, compiler type, programming language type techniques. And a lot of work is being done in this space. To name a few, Facebook has a large programming languages group. They've been now also publishing some of their work, and there's a lot of business value that they talk about when they basically talk about the advantage that the programming tools that they've developed have had on the developers of Facebook. And so one of the tools that I can recall is the Infer tool that basically is doing something like that. Google has a large compiler team, both static analysis and verification and optimization. All these hardware companies, Intel, Nvidia, ARM, they have large compiler teams. Yeah, and I'm sure I'm missing out many names here, but even from India, for example, right, Indian company like Tata, TCS, Tata Consultancy Services. I mean, they have a large verification team in Pune that is basically, developing PL tools for their own consumption and for and open sourcing them or kind of selling them. So I mean, there are lots and lots of there's lots of activity, and also, these are just ideas and techniques and frameworks, programming languages, compilers, and things like that. There's lots of applications that are branching out of it, right? I mean, there's verification, testing, optimization, of course, and then there's lots of other kind of system level things. People are using them in machine learning, so AI compilation. In fact, I recently read an article. Recently, I mean, it's been some time now, but there was this article from in a very visionary kind of forum where he was saying that they expect an explosion in the compilation space, and he was basically talking about it from the perspective of machine learning and AI, and saying that all these frameworks like PyTorch and TensorFlow, we really need very good compilers to be able to take advantage of the new architectures like GPUs and neuromorphic architectures and things like that. And so to be able to do that, there's going to be an explosion in that space. And he was just talking about that particular space, right? Not the entire compiler space. So yes, I mean, I hope that gives you some perspective of how and where these areas are going, both from a research and a commercial standpoint. Yes, Vipul.
Sir, I was just curious to know how much work is going in the theory side of this, like giving theoretical bounds or some like some sort of trade-off bounds between like performance and speed, like some sort of that thing.
Okay, so that's a very good question. What about the theoretical aspects of compiler design? What about the theoretical aspects of programming language design? Yes, there's work going on for sure. This is definitely a very, so first of all, I want to point out that compiler design and programming languages is basically one of those areas which has a very rich scope for both theory and systems. Okay, and I can't think of any other area in computer science which basically has this amount of rich mixture of the two spaces, and that makes it very, very interesting, right? Probably one of the most, I mean, at least I find it one of the most interesting aspects of computer science. So on the theory side, however, this is my personal perspective. This is actually a very old space from a theoretical perspective, and people have been working on the theoretical aspects of it for a long, long time. On the other hand, systems aspects are kind of more recent because the way the world has been evolving in terms of technology development, the availability of computing resources, the availability of storage resources, the availability of programming models, things like that. So I mean, those kind of things are developing. They have typically opened more avenues for systems research than for theory research, because it's the same theoretical ideas that apply here, they apply there, because it's, I mean, ultimately from a theoretical standpoint, from a fundamentals point of view, it's probably similar things with some boundaries. But I definitely think there must be, I'm not an expert, but there must be lots of new theoretical problems that are emerging because of these new frameworks, new programming languages, new settings, new environments. Yeah. And you know, if you want to look more about the study more about this, I would encourage you to look at, for example, the POPL conference, Principles of Programming Languages. So POPL is one of those venues. It's a top tier venue in programming languages. Publishes programming languages work, compiler work, and things like that. But it's one of those venues that is kind of more theory focused than the other venues and programming languages research. And so I would encourage you to look at that if you are interested. Yeah. Yeah, but I definitely believe that there must be lots of scope, even in the theory side of compiler design, given the speed at which these things are moving. Right. Thank you for the questions. More questions?
Hi. So I guess I have discussed this earlier with you, but maybe it would be a good question to discuss with the whole class. That and it is not specific to compilers research. It's more like how like what could be the possible steps to identify your research interests. So like I have been an undergraduate student here for like it's my final year, so it has been like over 3 years, and I'm interested in like more than one particular field. So how to narrow it down, how to be sure that okay, this is the research I want to do and this is the thing I want to carry on further. What could be the possible steps to that?
Okay, thanks Purva for the question. And indeed, that's a billion-dollar question, right? From a personal perspective, that what should be my choice, right? I mean, I would say even more than billion, right? Or whatever is the maximum amount, because that's what matters to a person, right? That whether you're making the right choices that are going to make you satisfied person at the end of the day. So. Yeah, I mean, of course, I don't have, I don't have a formula that this is what you should do, but here are some tips that one could use to basically try to narrow down their interests. Typically what you learn in UG is a very different flavor from what you have to do in your research, right? So, one thing that that I kind of learned is that UG is, I mean, courses are basically like analysis, and research, or I mean, just not just UG, but PG, any courses are basically like analysis. You're basically looking at existing work and then analyzing it and saying, oh yeah, this makes sense, or oh, why is this, why then you're asking questions, and then you're basically saying, okay, oh, now it makes sense, or okay, but I didn't really enjoy it, whatever, right? So that's what you're doing during courses. And then research is actually design. You actually, you're now basically looking at something and say, okay, let's design a solution for it. And you basically do. And these two activities are actually very, very different by their very nature. They're very different. And so one needs to basically get, in my opinion, some experience on the design side to be able to make these judgments for himself or herself, right? About whether they are liking it. Because at the end of the day, if you pick up that area, irrespective of whether you're picking it up for research or you're picking it up for, let's say, a job, or you're picking it up for whatever else, right? So I mean, point is, you're going to spend your day working in that space, right? And and typically it's not going to be analysis, right? I mean, that's just your learning kind of, that's just getting you up to speed to now start contributing. So the rest of your life you're going to start contributing, and so you need to get some experience for sure on that space, on that front, for all these different areas. Now, how do you do that? Of course, university is a great place because it gives you so many options, and it gives you a lightweight way of trying something, then backing out, trying something else, then backing out, because professors are usually, nice people, hopefully, and they're just going to say, okay, you are welcome to come try it out, and then if you don't like it, go ahead, no issues, right? And there are no kind of administrative issues associated with trying something and then backing out or something like that. So I would highly encourage that. I would also encourage, if you are not sure, so some of us are sometimes not sure whether to do research or whether to do a job, right? So I would say, if you are not sure, don't jump into any one option. Or I mean, I would just say job is probably the safer option. I mean, research is kind of, you get into it and it's almost like a commitment for a long time. Job is like you can kind of leave it anytime you like, right? So I would say take the safer option, right? Do the job. and then come back, because if you don't like, you will know, by when you take something, when you make the wrong bet, you will know for sure for yourself. And then, but then, one thing that I will guard against, which I see a lot, is that people actually take the option and then they're just they kind of keep complaining, but they are too lazy to change. Now that is, please don't do that. Don't complain. Okay, if you complain, that basically means you just don't have the energy or the courage to make your choices, right? Because you have the world at your feet, right, so to say. You can do whatever you like. It's not like you've been put into a jail to do something. You just made a choice, it didn't work out, take some other. So I'll share my own personal experience. For example, indeed, when I was in my 4th year, I wasn't sure about what I wanted to do, whether I wanted to do research or whether I wanted to do industry. For me, I wasn't I had some exposure of research, but I wasn't sure if that is, that's, and I didn't even know what is valued how much in the world, right? That's also part of my decision-making process. I need to know whether I want to get into something that's going to be valued. Irrespective of my interests and things like that. That's also part of my thing. And so, I definitely applied for jobs, and then I took up a job, and luckily I got a job which was in a research lab. So I kind of, it was kind of kind of flavor of both worlds. So I kind of got into that, got a flavor of industry, got a flavor of research, and then I made a nice choice for myself that, okay, I know that I want to learn more, pretty much. That was basically, I want to do research. I want to learn more about research. Let's put it like that. And then also it gave me a lot of clarity about what area I want to do. So that kind of stint at the research lab gave me one of the things about one. So I already mentioned one of the big positives of a university. You can do multiple things and stuff like that. But there's one negative of the university, that you can try different things as well. But there's one negative of the university as well. The negative is that it's a certain flavor of things that you get. Right? And that flavor is dictated, although there's a wide variety of things that our faculty members do. For example, our department is a very vibrant department. There, every faculty member has a different scope of their expertise, and they'll find lots of different areas. But even then, I would say there are some large spaces that are missing in the university that are present in the industry. Okay, so go ahead, get your get your experience in the industry if you're unsure. Understand that, okay, this is what understand those missing spaces, understand, firstly, make best use of your university time. Then if you're still unsure, go explore more things. Then have the courage to step back, think, and make an informed choice, right? So yeah, those are some things I can talk. That's some things that I can say.
That was helpful, actually. Yeah.
Okay, thank you.
Sir?
Yes,
yeah, I'm currently in my 4th year. I'm a dual degree student. I have one more year at IITD here. My interest in general was systems, and so far I've done your OS and compilers course and distributed systems, and I quite like this field. I think I want to specialize, go to grad school for this field. But I attended that PLMW mentoring session, and they kept saying that, well, you need research experience to be to go to grad school. But I'm not sure undergraduates here, like the kind of research exposure that we get, is that I don't know how to put this question.
Yeah, I think I understand your question. I guess you're asking about the amount of research exposure that you need to be able to apply for grad school, right?
Yeah.
And you're basically using this data point that you went to the PLMW workshop, and there people were telling you that you need some research exposure to be able to apply to grad school. Now, so first of all, I really don't think that research exposure in your UG is supposed to be a kind of segue into your. It's not like you're going to continue your UG research into your PG research. They're highly unlikely, right? What probably they mean there is that you get some research exposure, in the sense that you, as I kind of made this distinction between courses and research, right? So you've done a lot of courses, but at least you should have done some project. And IIT Delhi has a lot of kind of options for projects, BTech projects, or especially for dual degree students. I think that dual degree students actually in a better space in that sense, that because they have more time, they can kind of learn more. In fact, when I was a 4-year student, and in my 4th year I was really hoping that I wish I was a dual degree student. I mean, of course, then I got the research lab offer, and then I was fine with that, because I almost felt like I want to learn more, right? So so yes, I mean, the point is that, yeah, they probably mean by research experience, and that's something that I will also agree with, is that you need to have some exposure to research in general. You should have done a project, kind of done some of those things on your own, and then based on that you would have learned something about that space. Try to create something on your own. I would be surprised if people are asking for papers or anything like that. I really don't think so. I mean, if you get a paper, that's awesome. That really that's a stamp, that's a certificate that, okay, you actually started working on something and brought it to a certain level of maturity, that it actually, got published and stuff like that. But other than that, I really, I doubt that. I mean, but that's just an optional thing, and I really doubt that people are going to really look for that kind of stuff. Of course, it's a plus if you have it, but even if you can basically convince people that, okay, you have some, you kind of tried to explore these things. This is what you learned. This is what you did. Maybe it wasn't all the way to a full-blown paper, but at least something. Maybe your MTech thesis or something like that is pretty good.
Okay, thank you.
Okay, great. So, are there any other questions? I'm very happy to take more questions. But yes, Vipul.
So sorry, my webcam is not working. So just one general question, like for curiosity, like how was your experience with Sir Alex Icon, and how did it transform you over the time?
Oh, that's a very personal question to be discussing on a recorded session. But yeah, I mean, yeah, it was great. I'll just say that. And for sure, a PhD really, I won't talk about my advisor and things like that. But I mean, of course, I had a great experience. My advisor was great. And um, but in general, I would say that I'll talk about the process of PhD in general, and I thought it really, really transformed me in a big way. Firstly, I learned so many things. It's a totally different ball game, by the way, and it was also one of the toughest things I've done, probably, right? It is really, really difficult, I think, and because the learning curve is so steep. I mean, it's not so, like, today I am a professor, right? I mean, I'm a faculty member, and so now I can look back and say, oh, now I can do those things, and it seems easy now, right? Because I kind of learned many things now, but at that time it was very difficult for me, because I had to just pick up so many things and learn about firstly, it was a new environment, new everything is completely new, and I have to just cope up with everything simultaneously, and that just felt very difficult. But then, of course, I think it's the difficult things that transform you as well, right? So, yeah, probably I'll just say that.
If
Okay,
someone
great.
is too
Yeah, go ahead, Aditya.
if someone is too scared to go for a long commitment like a PhD, but still wants to explore research, kind of like you said about trying something and backing out, um, uh, master's research is still to some degree the same caliber as PhD research or not? Like, if I try master's research and say this is not for me or this is for me, is it the same as saying, like, if I can do this, I can do a PhD as well?
Okay. Yeah, that's a good question. Okay, I'll try to answer that question in detail. So I guess your question is, a PhD research is a big commitment. I want to get a flavor of research. Is master research going to give me that flavor or not? I would say yes, it would. Okay. Now, once again, see what happens is that PhD. So, okay, by the way, I didn't mean to scare you when I said it was very difficult or things like that. I mean, look, I'm very, I mean, I meant it in a positive way, not in a negative way in any way, right? So, I mean, after all, you are young. I mean, as young people, you should want to do difficult things, right? I mean, what's the point of doing easy things? I find it pretty, that would be boring, isn't it? I mean, you would want to do difficult things, and you should be
No,
okay to actually fail. No, it's not, I'm not picking on you, Aditya. I'm just kind of, I just wanted to make sure that the message is going across clearly and correctly.
no,
Okay.
I didn't say difficult as in like difficult is good, but the wrong kind of difficult is there's a difference between a trap that is difficult and something that is difficult that I want to do.
Yeah.
I saw something on Reddit about a machine learning PhD student who hated the kind of work that he was doing. Like that's the wrong kind of difficult to pursue, right?
Right. Yeah. I agree. So actually, that's what I would say. It's actually, I mean, the one of the difficulties here is to find something that is that way you can make an impact and something that you like, right? I mean, so that is one part of the difficulty. The other part of the difficulty is, if you have found what you like, then you make an impact, and that's an impactful area, whatever, and then you kind of make an impact there, right? So I would say the second thing is okay, easier than the first thing. I mean, once you find, it's the finding what you like thing, that phase of kind of matchmaking, that basically is the difficult part here. But that's one of the difficult parts here. Of course, the other part is also very difficult. But yeah, if you get stuck in the first part, that is, I think, the more thing. That is the thing to be concerned about more than the other part. Both things are difficult, by the way. So to answer your question, right? Indeed, master's research should give you a perspective on what PhD research would look like. But once again, it is about trial and error, in my opinion, right? I mean, you try something, you back out, you try. So it's very important that you're making use of this time in the best possible way, this time of master's research, before choosing your master's research advisor, before choosing your master's research problem, and things like that. So you have to keep doing this. And it's possible that while you're in the middle of your master's research, you feel like, okay, this is not something that I really enjoyed. But that doesn't mean you won't enjoy your PhD research. It probably means you need to kind of steer a little bit and kind of try something else, right? There's a bigger picture, and then there's a smaller picture. So when you are doing research, whether you're doing master research or you're in the initial years of your PhD research, you're always searching, right? So you're developing the smaller picture. Hopefully you will like the smaller picture, but if you don't, at least you're also developing the bigger picture. And when you develop, and from there, okay, maybe I'm not liking the smaller picture that I'm doing right now, but hey, by the way, in this time, I also developed the bigger picture, and I can kind of now go and try that point in that bigger picture, right? So I think that's how one should approach it, right? Right now, we don't, I mean, in the beginning, we will not have, neither have a smaller picture nor have a bigger picture. But as we kind of dive into something, we will develop both the small picture and the big picture. It's important that you do that. I mean, if you're just confining yourself to the small picture, you are not actually, doing service to yourself. You should be developing both the small picture and the big picture. And based on that, making choices, making your next steps. Okay, maybe I like the small picture. That's great. Or I don't like the small picture, but hey, but I kind of learned about this new thing. Let's try that now. And things like that. And it's okay. I mean, maybe, at the end of the day, you say, okay, I didn't okay, maybe research is not for me. That's also fine, right? But at least you tried everything, right? Everything that you were curious about. And that's, I mean, it's more about kind of satisfying your curiosity than anything else, at least. And that's how I think about it. Yeah, Jay.
So I want to ask something about MTPs. As a dual degree student, if I approach someone, so should I as in give an idea to work on that? I propose that we should work on this, or I should just approach someone and maybe the professor will give me something to work on and I'll take it as my MTP project. How does it work, and how should we do it as dual degree students?
I can share some advice, and and I'm just thinking about this advice on my feet right now. I mean, it's not like it's something that is a topic that I've thought about very deeply, but here is some advice. First of all, the professors or your seniors, whoever they may be, mentors in your industry or whatever, they're typically more experienced. So it'll be good to kind of give them that that margin that okay, maybe let's let them speak first, right? So I would say I would personally say just let them speak first. All right, ask them what are the problems. Okay, then I would even say maybe probe them a little bit, right? Okay, they give you a problem, then say okay, ask them questions, or maybe say are there some other problems that you're thinking about, or something like that, right? So probe people. I mean, just don't be shy of that. And then if you have an idea of your own, after he is done, after he or she is done, your the faculty member you're talking to, share your idea, right? And say, okay, what do you think about this? Okay, and then from there on, develop it. And now some people are going to be flexible, some people are going to be rigid. Okay, I know I don't want this, whatever, right? But that's all okay. I mean, but not. I mean, this is a nice, polite way of kind of learning about what the other person thinks, and then getting feedback on what you think, and from there on, developing the future course of action.
I mean, my question was a bit different. As in, I think you're talking about, let's say, if I'm actually working and we are discussing about a plan, as in, I'm working on that project. As in, what I'm talking about is like, I don't have an MTP yet. I have to, approach someone for getting an MTP. So, as in, let's say I want to work in this area. So, should I, so while asking for an MTP, should I give, okay, I want to work on this, this should be my area of my thesis, or will the professor give me something to work on?
No, I mean, so okay, so maybe I didn't understand the question, but I thought that's the question I answered, right? So basically, I'm saying that, look, when you approach a faculty member, right, you basically tell him or her that, okay, this is the wide area I work in, or maybe I like the courses and, I kind of want to work in this space. Or why are you wanting to work in the space that you're wanting to work in? That's wide space, right? So of course, if you approach a faculty member, for example, if you approach me, of course, you're not going to come to me and say, I want to do theoretical computer science, right? So of course, you have some basic idea that, okay, this is the space that I'm going to work in. That's going to be, and then maybe, I can share, okay, these are the problems that I think are meaningful here. And then, for an MTech project, from my perspective, it'll be, something that I want to scope for a 1.5 year period, things like that. That's really one of the challenges here. And then you can say okay, but so, and that's how the conversation proceeds, right? So didn't I answer your question, or
I thought it was a bit different. Yeah, I'm not answering it.
yeah. More thoughts on the discussion or questions? Yes, sir.
During the PLMW mentoring session, I also asked some questions about narrowing down advisors and schools. One advice that was given to me was it doesn't matter which school you go to, just find a good advisor, because that's going to shape your idea of research a lot. But nowhere have I found a good enough way of narrowing down an advisor. It's basically like mailing the lab's grad students and asking them how the work is like, and doesn't seem like a good enough way of figuring out if the advisor is good enough. Because how am I supposed to figure out if the advisor is good just through mails? And I didn't get any good answers for this question so far. So maybe you can share your personal experiences on this.
Yeah, so that's yeah. So I mean, A, you have to find an area, and B, you have to find an advisor, and they are actually correlated problems, and they are difficult problems. Okay, I mean, I hope I've already impressed upon you that these are difficult problems. Now, how does one go about doing that? Indeed, just sending emails to advisees and stuff like that, it will help. You should do it. but it's not the only thing that matters. Once again, I would say, getting some research experience will really improve your perspectives. Okay, develop the small picture, develop the big picture. That's going to give you a perspective of, where the field is going, what is the kind of work, what are the top venues, what are the top areas, what is getting, what matters in terms of, how do you evaluate, how to evaluate a potential advisor, right? All these things you learn only when you dive into research, right? You can't just, just do courses and then say, okay, let me look at this advisor or that advisor. I mean, how do you even kind of evaluate anybody, right? If you don't even know what the activity involves. Of course, you can look at the person's publication record or things like that. That's one thing. One important thing I would say, the advisor needs to be a nice person, in the sense that, I mean, he's going to be a friendly guy and somebody who's going to help you out in your difficult times. I think that's important. So that's on the personal side. He should be in that phase of his career, career where he's actually actively working on research. I mean, you don't want to end up with an advisor who's kind of, very accomplished, but kind of he's just, having a nice time now, and okay, another student, I don't mind, but don't have enough time to spend on you. Those are the kind of, non-technical aspects that you should look at. Also, I mean, on the flip side is that you go to an advisor who's kind of really super charged about doing that. I mean, he's like super intense, right? I mean, maybe you are not that kind of person who's that intense, and then you kind of feel caged because of that. So you have to guard against that as well. So yeah, I mean, those are some non-technical things. On the technical front, I think the only way to evaluate somebody is by diving into areas yourself. Maybe not with that person, but if you can with that person, that's great, and then with an option of stepping out and things like that. But maybe that's one place where prior research experience will really help, right? That you kind of use your let's say master's degree time or something like that to kind of really read papers, try to work on research yourself, understand the area, and things like that. For me personally, when I did my research lab stint, it really gave me a perspective. I really understood different areas of research, different who's doing what. Also, the research lab was very nice because I had some senior people around me who were sharing their own perspectives about what is good, what is bad, and that kind of stuff. So that really helped me a lot. And so that's my personal experience. Yeah. And so I should point out, by the way, because I had this 1 year gap between my applying to grad school and my UG, I really had more perspective. And I could feel that when I actually entered grad school, people who didn't have this kind of exposure were more confused about which area to go for, how to choose an advisor and stuff like that. And I was much clearer, I felt, at least, that's my personal kind of feeling. Of course, maybe other people didn't feel like that, but at least I definitely felt it was a lot of value to kind of get that perspective before applying. You can also try to get that perspective after you join that place, but it's harder because now, the faculty member at the other place is going to, you kind of join a faculty member. There are all kinds of funding strings attached to it. Now pulling out becomes a slightly harder problem. On the other hand, if you kind of get that perspective earlier before even applying, in my opinion, that's what I did. And that worked out well for me, I thought. Yeah.
Can a 2 degree student's last year, where he basically only does research, will that equate to a research lab experience or not?
To some degree, yes. Yes, why not? To some degree, depends on how hard you work. And yeah, to some degree, yes, for sure. So for example, I'll share an example. I just last year I had a couple of students who worked on a project. So I have to say, when you start off a project, it's basically you are really engaged. B, the faculty members also really engage with you. That's very important, right? Sometimes what happens is faculty members take these projects lightly, which is not a good situation for you to be in. Unfortunately, that happens. But it's just a matter of fact thing, right? Because everybody's busy with so much stuff going around, right? Faculty members have a lot to do. So to be fair to them, it's not their fault really. But if you can, I mean, if that fit happens, right, it's very important that the faculty member is very involved in your work. Very means, you know, whenever you ask for a meeting, he or she is giving you a meeting, and, you know, sharing his or her thoughts, spending time with you where it needs to be spent. And then you are being responsive, and then you're going back and following up on it, and then coming back. And if you're doing that cycle correctly, then you know, I think a dual degree of space, this 1 year, 1.5 years, is excellent opportunity. I can share with you my personal experience over the past 10 or 11 years that I've been at IIT Delhi. I have had 2 top tier papers with dual degree students alone. I mean, no PhD student involved whatsoever. No work done by me in that in those papers at all, right? And these are just the things that actually happened as big papers, right? But there's a lot of other dual degree students that I kind of worked with, which did great work, great thesis, and I felt like they got their perspective. I got my research goals out of them, and almost all of them were basically people who are actually doing this very tight loop with me on kind of doing the doing discussions with me, and then going back and following up in a short amount of time, let's say a week or something, and then coming back and saying, well, this is what I have, what do you think? And then kind of doing that. And so, you know, doing that in an honest and enthusiastic way is definitely going to help, in my opinion. Yeah. So dual degree students have a much bigger edge, in my opinion, on that front, because they have that time. No, I've never been able to do anything meaningful for BTech students. I'm sorry to say that, but because just the time is short, right? And you guys are so busy and stuff like that. So, but. Okay.
So can I ask some questions about the project that I'm currently involved in with you? Because I have some questions there. It's meta level questions, not particular.
Okay, maybe we can do that later. I mean, you know, given that this is a common forum, maybe it's not, or do you, why don't you go ahead with the questions, and I can kind of say that, okay, maybe we want to discuss it right now, or we can do it later. Yeah.
For example, the paper that I'm reading, I'm not sure how other people read it, but I couldn't understand in one single shot, and even now I still can't understand some parts of it. Like, it's a very slow process. Is that normal, or does that?
That's absolutely normal, by the way, right? Okay, so let me tell you about. So, you know, that's what I said. It was really difficult in the beginning, right? So now I can kind of easily read papers, and I can say, okay, so no, what's the big deal? But, you know, at that point, it's really difficult to absorb papers. Firstly, there are so many papers, right? You feel like, I mean, reading one paper is so difficult. I mean, and then there are 100 papers on the pile. Like, I mean, this just seems impossible, right? And that's actually very true. But then then slowly you learn. First, it's very important to understand that one paper. Forget about the rest 99. Just at least read that one paper properly. And of course, it's not going to be readable in the first reading. Please don't expect that at all. Okay, especially in maybe, you know, it's true for other areas, true too, but especially for systems areas, I can say that that's not the way. You know, you cannot read the paper in one reading for sure, especially if you are a new guy, new person on the blog. What you need to do is you need to read the paper once, then do some talking around, understanding more about things, then read the paper again, and keep doing this iteration, right? And you're going to keep learning new things. Each time you read the paper, you're going to keep learning new things about that piece of work, I feel. Of course, until you reach a saturation point. Yeah, so I will share with you my experience, by the way, on reading papers. So when I joined grad school, this was at Stanford, I, of course, didn't know how to read papers. I did. I had read some papers in my research lab, but they were, so I had read papers in the spaces of theory. So, you know, initially I used to be very interested in theoretical computer science. which you may surprise you, by the way. So I read a lot of papers in theory. In fact, I also tried to publish a paper in theory. It didn't really go anywhere. I did read papers in databases, data mining, those kind of areas. But then when I started grad school, I started try to read some systems paper, because that's what I got interested in. I wanted to go deeper into the software stack, and I wanted to look at what an operating system looks like, all those kind of things. So I started reading, but I couldn't really understand the operating system paper at all. Even though I had read, DB papers and theory papers in the past, I really couldn't understand anything from the OS paper. So that actually made me more interested, that okay, I cannot understand this, so I need to learn more. So I basically, one thing really helped me was a grads level class, which is called Advanced Operating Systems in Stanford. And there basically the whole class was about reading papers, right? So we're just going to read one. So every week we'll read a different paper. The way the class was structured was we need to read the paper before we turn up for the class. And in the class, we would just discuss the paper. To me, that was a really kind of, it was a great class in my opinion. I just learned how, I would read the paper, but then I come to class and then I would learn so many other things that I just didn't catch from the paper. And then I would go back and then reread the paper, and then there will be an exam on those papers as well, right? So I would read them at least twice, maybe, right? So that was great. So yeah, something like that. I'm just sharing my experience. So maybe there are some courses at IIT Delhi as well, which are doing that. I used to offer a paper reading course, which was an 800 level course earlier, and we used to read the papers. I used to ask students to read the paper before the class, but mostly people won't read the paper before the class. And basically what the class used to be basically me describing the paper and things like that. So please avoid that. You're not really taking full advantage of the course if you're not actually following the idea of the course. Yeah, Purva?
Yeah, so actually I wanted to share my paper reading experience of like past 6 months. So I'm currently doing this BTech project with Professor Parag, and we have been trying to apply techniques used for one particular task to some other task. So there's this paper that does that technique, and it's a 15-page paper, and I have read it up like minimum 20 times up till now, and still whenever I read it, I find something new that, oh, I didn't know this about the technique, and this would really help in taking the work forward. So I just wanted to share that, I think all the students at my level have been struggling with this, that reading a paper once or even 20 times is sometimes not enough.
Yeah, absolutely. Thanks for sharing that experience. All right, I think we had a very nice, interesting, and long discussion. I really enjoyed it, and I'm glad that we have recorded it. So, maybe other people may find it interesting. I don't know. Great, thank you. And I really enjoyed doing this online version of the course. I got some feedback from last time from all of you as well, that you enjoyed it as well, which is great, because yeah, I wasn't sure how, because of very little interaction in this online mode, but at least that's great. Yeah, so thank you. Maybe, if there are any comments or thoughts on the end, and then we can just find this out. Okay, great. Thank you, and see you at the majors. Okay.
Thank you. Bye-bye.
Bye.
Bye. Thank you, sir.
Thanks.
Thank you, sir.